Hello viewers, in today's session we are going to discuss another important conceptual problem from three-dimensional geometry. And here in this class we are going to find out the distance of a point from a plane measured parallel to some given line, right? So here our topic is distance of a point from a line, and here we have this problem: find the distance of the point. The coordinates are 1 comma minus 1 comma 2, and we have to find the distance of this point from this plane x plus y plus z is equal to 5, measured parallel to the line whose equation is x minus 1 over 2 equal to y minus 3 over 3 equal to z plus 2 over minus 6, right? So here we'll see how we can find out the distance of a point from a plane measured parallel to some given line. So now let us understand this problem with the help of a diagram. Now see, here we have the plane whose equation is given as x plus y plus z is equal to 5, right? And we have to find the distance of this point. Let us consider the point over here. We have 1 minus 1 2, and we have to find the distance of this point from this plane, right? So we have to find this distance, and remember this distance is not the perpendicular distance of this point from this plane, because we have to measure this distance parallel to this line, and the line is given as x minus 1 over 2, y minus 3 over 3, z plus 2 over minus 6. So now we have to find this distance AM, where A is 1 minus 1 2, and we have to find the coordinates of this point M, which lies on this plane x plus y plus z is equal to 5, right? So our first aim is to get the coordinates of this point M, so that we can utilize the distance formula, that is distance between 2 points, right? And the formula for distance between 2 points, say x1 y1 z1 and x2 y2 z2, is given by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, right? So am is given by this formula. So we have to first find out the coordinates of this point M. So now this segment, that is AM, is parallel to the given line L, right? And here this line, that is AM, is parallel to L. So the direction ratios of the line L and AM are proportional, and the direction ratios of the line L are given by 2, 3 and minus 6, right? So now let us write the equation of AM. So equation of AM is given by x minus say x1 over a, y minus y1 over b, and z minus z1 over c. Now x1 y1 z1 is the point lying on this line AM. So we can consider x1 y1 z1 as 1 minus 1 and 2, and a b c are the direction ratios of AM. Now AM is parallel to the line L, and when we have two parallel lines, their direction ratios are proportional. So we can take the direction ratios of AM, that is ABC, as 2, 3 and minus 6, right? 2, 3 and minus 6. So now the equation of this line AM is given by x minus 1 over 2. Then we have y minus, y1 is minus 1. So here we have plus 1 and b is 3. And here we have z minus z1. Z1 is 2 and c is minus 6, right? So this is the equation of AM, which is parallel to the given line L. So now consider a scalar r over here, right? So here r is some real number and it is a scalar. So the coordinates of this point M may be obtained from this equation, right? So we can now write x minus 1 over 2 is equal to r, y plus 1 over 3 is equal to r, z minus 2 over minus 6 is equal to r. So solving these three equations for x, y and z, we have x is equal to 2r plus 1, y is 3r minus 1 and z is minus 6r plus 2, right? So 2r plus 1 comma 3r minus 1 comma minus 6r plus 2 are the coordinates of a general point lying on this line AM. And for some value of r, we can take this coordinate as this one. So we can now take the coordinates of M as 2r plus 1, 3r minus 1, minus 6r plus 2 for some value of r. So now this point M lies on AM as well as on the plane x plus y plus z is equal to 5. So this point M satisfies the equation of the plane. So we can now take x, y, z in terms of r and we can substitute this coordinate in the equation of the plane P, because M lies on the plane, right? So we have for x we can write 2r plus 1, for y we can have 3r minus 1, then for z we can write minus 6r plus 2 is equal to 5. So now this is a linear equation in r and we can solve it for r. So this is 3 plus 2, 5. 5 minus 6 is minus 1. So we have minus r. Here 1 and 1 get cancelled. And here we have plus 2, that is equal to 5. So we have now minus r is equal to 5 minus 2. So minus r is equal to 3. So r is equal to 3, minus 3, right? So r is equal to negative 3. So for r is equal to negative 3, this point that is M, it lies on the given plane P. So now the coordinates of M can be obtained by taking r is equal to minus 3 in this coordinate. So we have 2 times minus 3 plus 1. Here we have 3 minus 1. Then we have minus 6 minus 3 plus 2. So M is now given by minus 6 plus 1. Here we have minus 9 minus 1 and here we have 18 plus 2, that is equal to minus 5. Here we have minus 10 and here we have 20, right? So the coordinates of the point M are minus 5 comma minus 10 comma 20. So now here M can be written as minus 5 comma minus 10 and 20. So now this distance AM can be calculated from distance formula. See, here we have x1, y1, z1 and this coordinate may be taken as x2, y2, z2, right? So we have x2 minus x1 square. So we have minus 5 minus 1 square. Then we have minus 10 minus 1 square, and then we have 20 minus 2 square. So So now we can solve this expression. Here we have minus 6 square. This is minus 6 square. Here we have minus 10 plus 1, that is minus 9 square, and here we have 18 square, right? So this is minus 6 square is 36. This is minus 9 square is 81, and 18 square is 324. So now when we add up these three numbers, we get 441, right? And the square root of 441 is equal to 21, right? So now the distance of this point A from this plane P, which is measured parallel to this line, is given by 21 units. So this is how with the help of these concepts we can find out the distance of a point from a given plane measured parallel to some given line.